Section 3.5 Specific Heat. Every substance has its own characteristic ability to absorb heat. When you bake a potato, you place it in a hot oven. If you're cooking pasta, you add the pasta to boiling water. You already know that adding heat to water increases the temperature until it boils. Certain substances absorb more heat and than others to reach a certain temperature. The energy requirements for different substances are described in terms of physical property called specific heat. The specific heat of a substance is defined as the amount of heat, Q, in joules or calories needed to change the temperature of exactly 1 gram of substance 1 degree Celsius. To calculate the specific heat of a substance, we measure the heat in joules, the mass in grams, and the temperature change, which is written as delta T. The symbol delta means change in. For example, the specific heat of water is 4.184 joules per gram per degree Celsius. Specific heat is heat over mass times the change in temperature, which is joules divided by grams degrees Celsius. The specific heat of water is 4.84 joules for every gram times degrees Celsius. If we look at table 3.8, we see that 1 gram of water requires 4.184 joules to increase its temperature by 1 degree Celsius. Water has a large specific heat that's about 5 times the specific heat of aluminum. Aluminum has a specific heat that's about twice that of copper. Therefore, 4.14 joules will increase the temperature of 1 gram of water by 1 degree Celsius, whereas the same amount of heat, 4.184 joules, will increase the 1 gram of aluminum by 5 degrees Celsius and 1 gram of copper by 10 degrees Celsius. The low specific heats of aluminum and copper mean they transfer heat efficiently, which makes them useful in cookware. The high specific heat of liquid water has a major impact on the temperatures in a coastal city compared to an inland city. A large mass of water near a coastal city can absorb or release 5 times the energy absorbed or released in the same mass of rock near an inland city. This means that in the summer, a body of water absorbs large quantities of heat, which cools in a coastal city, and in the winter, the same body of water releases large quantities of heat, which provides warmer temperatures. A similar effect happens within our bodies, which contain 70% by mass water. Water in the body absorbs and releases large quantities of heat in order to maintain an almost constant body temperature. Heat from specific heat equation. It's often helpful to know the quantity of heat, Q, absorbed or lost by a substance. The heat equation is derived from the specific heat relationship when we multiply both sides by m and delta T. Specific heat is heat, Q, divide per amount of material, m, times the change in temperature. So mass times delta T times the specific heat equals Q. However, this ability of these and other